Okay, guys, thanks for giving me some of your 8th period to work on pre-algebra. I want to talk about probability and statistics. So today we're going to start with basic probability. Now, I've got some words that we're going to talk about, and we're going to start with event. Now, as I've said a bunch of times, mathematicians are not creative when it comes to naming stuff. We use boring names. So an event is just something that happens, okay? It is the result of a probability experiment. So something along the lines of you roll a die and it shows a number 4. So you roll a die and it shows 4. Okay, that would be an event. Okay, it's the result of a very simple probability experiment. I'll make this one a little smaller and we'll make it green. Okay, then we have probability. Okay, now probability, this is something you're probably a little bit more comfortable with. Okay, probability basically means how likely something is to happen, your chances of something happening. So if I ask you what was the probability of that die showing a 4, well, you know that a die has 6 sides and only one of them's 4, so that would be 1 out of 6. Okay, but more mathematically speaking, okay, if we want to give it a better mathematical definition, it is the ratio of successful outcomes to possible outcomes. Okay, so like we said, for that experiment above, that would be 1/6 for the experiment above. Okay, and let me make this look more like 1/6. And shift stuff a little bit. Okay, so these first two go with the event. The next two go with probability. And then this last one's complement. Now, it's not like saying, oh, your hair looks pretty today. It's not that kind of compliment. This is complement meaning something that goes together. So what goes together with an event would be everything that's not that event. Now, that's kind of weird to talk about, but what it is all outcomes from an experiment that are not the success or the described outcome. Okay, everything that's not the one that's described. So above, we talked about the probability of rolling a 4. Well, the complement of rolling a 4 would be everything that's not a 4. So 1, 2, 3, 5, and 6. That would be the complement. So complement is just everything else, everything that's not the one that you're originally talking about. Okay, so those are our definitions. We're going to use those words pretty regularly, so we want to make sure that we know them. Now, probability, here's the thing about probability. Every single answer you could possibly get for probability, all answers, are going to be between two numbers. They're going to be between 0 and 1. So any probability that you could possibly find is going to be between those two numbers. Now, 0, also 0%, also any fraction with 0 on the top. 1, what 1 is as a percent is 100%. Okay, if you have a 1, that means that it's 100% probability. Now, 0 probability means that it can't happen. It's impossible. A probability of 1 or 100% means that it is definitely going to happen. It's what's called a certain event. Okay, it is guaranteed. Now, halfway between those two, well, halfway, 1/2. Okay, or 0.5, or 50%. This is what's called equally likely. Because it's equally likely to happen or not happen. It's a 50-50 shot. It's like flipping a coin. You might get heads, you might get tails, and you have an equal opportunity to get either one of those. That's what equally likely is. Then you get the gray area between these two. So anything from 0 to 1/2, anything from 0 to 50%, we call those events unlikely. Okay, so there's 94 students in 7th grade, and I pick one of them. What's the probability that I pick you? Well, that's going to be 1 out of 94, which is a pretty unlikely probability. Okay, but then you have on the other side anything between 50% and 100%. We call those likely events. Okay, if there's 94 students in the 7th grade and say 60 of them are boys, what's the probability that I pick a boy? Well, that would be 60 out of 94, which is fairly likely. That's a pretty good probability. Okay, so these are the things that we're going to talk about. These are the words that we're going to use. These are the things we need to get comfortable with saying. How to determine probability. Okay, this is the one that I think you guys will probably be pretty comfortable with. Okay, first thing that we're going to do is we're going to count the possible outcomes. How many things could possibly happen? Now, we're not always going to have to sit there and count 1, 2, 3, 4. A lot of times that number is given to us. But I count all the possible outcomes for an experiment. So rolling a die, there's 6 possible outcomes. Flipping a coin, there's 2 possible outcomes. Then I want to think about counting the successes, the possible successes, or the successful outcomes. And I'll spell it correctly eventually. Okay, then once I have those 2 numbers, I'm going to set up the ratio. Okay, and I'll tell you what that ratio is in just a second, but I'll set up that ratio, and it's going to look like a fraction. And what we always do with fractions is we simplify. Always, always, always simplify your fractions. Now, here's what this ratio is going to look like. Okay, it's going to look like successes over possible. How many successful outcomes there are divided by how many possible outcomes there are. And most of the time, guys, we're going to be able to simplify. So make sure that you do. Always, always simplify. Sometimes they might ask for a decimal answer. Sometimes they might ask for a percent answer. But the key is to simplify your fractions. Okay, so number 1, I have a bowl containing 12 slips of paper, each with a different name of the month. Find the probability that a slip selected at random from the bowl has the name of a month that starts with a J. Okay, so my possible outcomes. We're talking about 12 slips of paper, each with a different name of the month. Well, that means that there are 12 possibilities. There's 12 total possible outcomes. Our successes, okay, we want the ones that start with a J. So think about your months. You've got January, February, March, April, May, June, July, August, September, October, November, December. So we have 3 successful outcomes. So our ratio of successes to possible outcomes is 3 over 12. We always, always, always want to reduce the fraction. So 3/12 reduces to 1/4. So we can say the probability of selecting a month starting with J is 1/4. Okay, number 2. After receiving complaints, a skateboard manufacturer inspected 1,000 skateboards at random. The manufacturer found 992 skateboards without defects. What is the probability that a skateboard randomly selected from the inspection had no defects? So we want to think about the possible outcomes, the successful outcomes, and then we can make a ratio with those two. Well, they said that they inspected 1,000 skateboards. That's the total possible outcomes. There are 1,000 skateboards that they looked at. Okay, so each one of those skateboards was one possible event, one possible outcome. The successes would be that the skateboard had no defects, meaning the skateboard was perfectly okay. Well, if we look through the story, 992 of them were without defects. So the successes would be 992. So our ratio would be 992 over 1,000. And we can reduce that fraction a couple of times, and we'll end up with 124 over 125. So the probability of a skateboard having no defects is 124 out of 125. Okay, number 3, you roll a fair six-sided die. What is the probability that you do not roll a number greater than 3? Well, possible, your successes, and then we can talk about the ratio. Well, the possible outcomes, if you're rolling a fair six-sided die, there's 6 possible outcomes. Then we want to know about the probability you do not roll a number greater than 3. So what are the numbers that are not greater than 3? Well, 1 is not greater than 3. 2 is not greater than 3. What about 3 itself? Well, it says not greater than 3. 3 is not greater than 3. So 3 would be one of our successes. So that means there are 3 possible successful outcomes. So our ratio would be 3 over 6, which we could give as 1/2. And we'd say the probability of the die, or of rolling a number not greater than 3 is 1/2. Now let's take a time out and let's look at each of these 3 probabilities. Okay, one probability, ooh, that's not what I wanted. One probability was 1/4. Another probability was 124 out of 125. And then this last probability was 1/2. Let's think about, are these likely, unlikely, or equally likely? Well, 1/4. 1/4 is between 0 and 1/2, which means it is unlikely. If we look at the scale up near the top of the page, we'll see that 1/4 is between 0 and 1/2, and anything in that range we'd call unlikely. How about 124 over 125? Okay, well, that's kind of a weird fraction. I'm probably not super comfortable with our 125th. So what we can do is get the decimal. Do 124 divided by 125, and we get 0.992. Well, 0.992 is really, really close to 1. So I would say this is a likely event. How about 1/2? 1/2, well, that's smack dab in the middle. This is an equally likely event. Try number 4 on your own. And if you're going to try this on your own, hit pause right now so you don't see the answer just yet. So we have 8 possible outcomes, and they want a number greater than 6. Well, is 6 greater than 6? Of course it isn't. It's equal to 6. So all we have, the only successful outcomes would be 7 and 8, which is 2. So our ratio would be 2 successful outcomes over 8 possible outcomes, which we can reduce to 1/4. So the probability of spinning a number greater than 6 is 1/4. Okay, let's flip over to the back. On the back, we start talking about something called frequency. Now, frequency talks about how frequent an event is. So the actual definition of frequency would be the number of times we can expect an event to occur. So for instance, if I roll a die 20 times, how many times can I expect it to show a 6? Okay, well, that's the kind of question that we want to find out. Well, to find that frequency, what you do is you multiply the probability of the event by the number of trials. Okay, how many times you're going to do it. So if you're rolling that die 20 times, and you want that probability that you roll a 6, you would do 1 out of 6, because that's the probability of rolling that 6, times the 20 times that you're rolling the die. Well, with that in mind, let's look at example 6 here. Okay, example 6, they say you roll a fair 6-sided die 20 times. Hey, how about that? How many times can you expect it to show a 1 or a 2? So they're asking for the frequency, the expected frequency. Okay, well, if we roll a fair 6-sided die, we can say the probability of a 1 or a 2 is 2 out of 6. Because there's two possible successful outcomes. There's the 1 and the 2. And there's 6 possible outcomes, so 2 out of 6, which is equal to 1/3. Now, to find that frequency, we're going to take that 1/3, the probability, times the number of trials, 20. So I can put that 20 over 1, multiply straight across, and get 20 over 3. Okay, well, 20/3 is kind of weird. So what we would do is either turn that into a mixed number or a decimal. Now, I would say just go for the decimal. Do 20 divided by 3, and what you're going to get is 6.6 repeating. Now, this is the frequency. This is how many times we can expect that to happen. Well, we can't have part of a time happen. It's either going to happen 6 times or it's going to happen 7 times. It can't possibly happen 6.6 repeating times. So what we say is we can expect a 1 or 2 either 6 or 7 times. Okay, let's look at number 5. If you flip a coin 30 times, how many times can you expect it to show tails? So first up, I need the probability of tails. One single coin flip, what's the probability that it shows tails? Well, there's 2 possible outcomes, either heads or tails. Only one of them is the successful outcome. So I would take 1/2 for my probability of the coin flip showing tails. Now, to find that frequency, we would take that probability and we'd multiply it by the number of trials, 30. And I could put that 30 over 1, multiply straight across, get 30 over 2, which is 15. So we can say that we can expect tails 15 times. Now here's the deal with both of those. If you flip a coin 30 times, you're probably not going to get exactly 15 heads and exactly 15 tails. You might get 16 and 14. You might get 17 and 13. You might even get something like 10 and 20. Okay, there's no real way to guarantee that you're going to split those results 50-50, but it should be pretty close. You're probably not going to see 29 heads and only 1 tails. So keep that in mind when you're looking at your results. Okay, how about number 7? Take a look at number 7 and actually try this one on your own. And if you're going to try it on your own, pause right now so you don't see the results. So the table below shows the favorite class for 20 students. If the 7th grade has 94 students, how many could we expect to say that math is their favorite subject? So right now, we're going to focus on just the math column. Okay, those ones we could use to answer other questions, but since we're only focused on math, let's just think about math. So in this study, there are 20 students. 20 students were asked this question. So if I want the probability, I'm going to abbreviate this time, the probability of the student's favorite class being math, that would be 6 of those students out of the 20 that were asked. And we can reduce that down to 3/10. So the probability of the student saying that math is their favorite subject is 3/10. Now, if I want the frequency, what I need to do is take that 3/10 and multiply it by the 94 total students in the grade. Okay, and if I put that 94 over 1 and multiply straight across, I'll get 282 over 10. And if I divide that, or if I reduce it, I'll end up with 28.2. Now the frequency this time, guys, they're asking how many students could we expect to say that math is their favorite subject? Obviously, we can't have part of a student, so we need to decide, should that be 28 or should it be 22? Well, you could really make a case for either argument. So what we'll say is that we can expect 28 or 29 students to say math is their favorite. All right, so a quick recap, okay? An event is just the result of one probability experiment. You roll the die one time and it shows a 4. Probability is the ratio of successful outcomes to possible outcomes. So if we're rolling the die and it's showing 4, that was 1/6. Now, probability is usually as a fraction or decimal. Sometimes when you're talking about it, you might use percent, but you're usually going to talk about it with either a fraction or a decimal. Complement is just everything that is not described as the successful outcome. So for this example we were talking about rolling a die and it's showing a 4, 1, 2, 3, 5, and 6 would be the complements. Probability exists between 0 and 1. Every single probability answer you get is going to be between 0 and 1. So to find probability, we take our possible outcomes, we take our successful outcomes, and we divide them. Successes over possible, and always, always, always simplify. If we want to find the frequency of an event, we take the probability of that event occurring, and we multiply it by the number of times we try that event.